Hi guys, hello everyone, this is Saurav here and welcome to the Vedantu VOS channel. In these sessions, we'll be covering certain important reagents which usually people miss and they find themselves in a lot of trouble. We will be starting with diazomethane as this is one of the most versatile organic compounds and reagents which is being utilized to perform a lot of synthesis reactions. In the upcoming sessions as well, we'll be picking up certain important reagents and we'll study the history of these reagents, what are the properties and what are the chemical reactions that they give so that you can make a very informed choice about what is the purpose of using this reagent and how do you manipulate these reagents in a certain step of your synthesis. So चलिए आज का सेशन स्टार्ट करते हैं एंड आज का सेशन हमारा है diazomethane पर. Diazomethane was in fact discovered by Hans von Pechmann. Okay, he was German chemist and he discovered diazomethane by two methods. So आज हम वो methods पढ़ेंगे and let's start today's session. So the von Pechmann method, the first method of synthesis of diazomethane. Diazomethane को आपने बहुत जगह देखा होगा. Diazomethane is being utilized to create cyclopropyl systems. Diazomethane is used to prepare, it is utilized in Wolff rearrangement जो हमने पहले भी पढ़ा है. So let's see from where it is being obtained. What is the structure? What are the chemical properties? What are the physical properties? The first method is from N-methyl N-nitrosourea. If I look at this structure, this is urea. Okay, इसको ये तो सभी लोग जानते हैं ये यूरिया है. इसमें हम करते क्या है? सबसे पहले यूरिया is being made to react with, you take the ammonium salt of methylamine. मतलब अगर आपने मिथाइलअमीन लिया CH3NH2 and इसको अगर आपने HCl के साथ ट्रीट कर दिया, then you will be getting CH3NH3 positive Cl minus. हमें इसी कंपाउंड को इसके साथ रिएक्शन कराना है. तो होता क्या है? When this compound reacts with CH3 ammonium salt of methylamine under the influence of heat, we get a compound like this. You get a methyl urea. यहाँ पे एक मिथाइल ग्रुप है और ये पूरा यूरिया का यूनिट था. So this becomes a methyl urea unit. Methyl urea is being treated with HNO2. And if you know for a fact that if you take a 2-degree amine RNHR and this is being made to react with HNO2, HNO2 gives out NO plus और ये चीज RNHR के साथ रिएक्शन करके RNN डबल बॉन्ड OH यहाँ पे पॉजिटिव चार्ज आता है R and then this loses a proton and it creates R N N double bond O R. हमने ये पढ़ा भी है कि if you take a 2-degree amine you get a nitrosamine. So this is a yellow colored nitrosamine or oily nitrosamine that we get. Similarly ये जो एक 2-degree amine के जैसा दिखने वाला पार्ट है, this part gets converted to the nitrosourea part. So over here at this nitrogen, a N double bond O is created and this one is treated with KOH. Then we get actually CH2 and 2 हमें मिल जाता है. Let's look at how this last step takes place. क्योंकि ये जो step है ये तो is pretty easy to understand. This nitrogen must have attacked this carbon and this NH3 would have gotten released and we would have obtained NH4Cl. So this step is easy, as well as this step I have already explained right now. It's very similar to R2NH reaction with HNO2. Okay, let's look at the last reaction कि यहाँ पे क्या हो रहा है. So This is your compound NH2 C double bond O N double bond O CH3. अब होता क्या है कि OH minus reacts in the very first step, and OH minus attacks the carbonyl carbon and it generates something like this. I'll get NH2 CO minus OH N double bond O CH3. Now what happens? This comes over here, this comes over here, and this comes over here. मैं इसको 1 लिख देता हूँ, इसको 2 लिख देता हूँ, इसको 3 लिख देता हूँ. मतलब कि this is the chronological order in which the bonds are breaking or the electrons are moving. So we would be getting something like this: NH2 C double bond O OH plus CH3 N double bond N O minus. In fact, what happens is that this species further reacts with H2O and actually methyl MEOH है ना, methyl alcohol. So H2O नहीं है, we have methyl alcohol. So it reacts with MEOH to generate CH3 N double bond N OH. And after this step, OH minus, which was present in the medium, it does a very interesting step. I would say ऐसा reaction आपने पहले भी देखा है, but let me just write this over here that what it does. So CH2, there is H, and ये भाई साहब OH minus के साथ reaction करते हैं. OH minus takes this proton, this comes over here, this comes over here, and this goes out. Okay? Is that clear? So eventually आप इसको ऐसे भी कर सकते हो कि you just write this. If you do not want to make this clumsy, you just write this first. Okay, this will create CH2 minus N double bond N OH. Okay, it will create this, and then what you do is you use these lone pair of electrons over here and displace this OH, and you end up getting your compound, which is diazomethane. This is what you obtain. यही कंपाउंड आपका डाइएजोमीथेन बन जाता है, CH2 NH2. Sorry, CH2N2, not NH2, CH2N2. I'm very sorry for that. Now, please remember that this compound is also not quite stable. This compound is also not quite stable. So, it will react with OH minus, which is present in the medium. मैं इसको यहाँ पे लिख देता हूँ. So, NH2 C double bond O OH will react with OH minus, and it will take up this proton, and it will create a NH2 minus C double bond O डबल बॉन्ड O और वाटर रहता है, एंड ये दोनों एक एसिड बेस रिएक्शन में पार्टिसिपेट करते हैं एंड इट जनरेट्स NH3 प्लस OH माइनस फिर से लिबरेट कर जाता है. सो यू कैन सी दिस होल रिएक्शन involves the conversion of the N-methyl N-nitrosourea to diazomethane. Now please do remember that this is a very exotic step of the reaction. We do not usually see this happen in other places. Why is this happening? Is because apart from this group, other groups are not good leaving groups, and therefore this has to leave. And the product which is created is not that stable, but it can be converted into a stable. What is the driving force? कि ये कार्बोनेट बन गया, आपके पास ये CO2 जो है वो कार्बोनेट में कन्वर्ट हो जाता है. CO2 क्या कर सकता है? OH माइनस के साथ रिएक्शन करके कार्बोनेट में कन्वर्ट हो सकता है, CO3 2 माइनस में कन्वर्ट हो जाएगा, एंड carbonate ammonia, so carbonate gets precipitated, ammonia gets liberated, this is also liberated as a gas, so that drives the reaction in the forward directions. This is the von Pechmann method. von Pechmann method दो तरह के होते हैं. एक होता है जहां पर कि N-methyl N-nitrosourea से हम diazomethane create करते हैं. Another one is where we use N-methylurethane. What is N-methylurethane? So what you do is you take primary amine and react it with chloroester. Okay, Cl C double bond OOET. When you react this, a typical, so how would this reaction look like? CH3NH2 plus Cl C double bond OOET. Cl is a better leaving group, so this will attack over here. Cl will go out. Finally, it will remove a proton, and we would get CH3NH C double bond OOET. This is exactly this compound N-methylurethane. देखिए N-methylurethane आपने यहाँ पे create कर दिया. Okay. Now please look over here that you are again using HNO2, and HNO2 is again going to do the same thing that it was doing earlier. HNO2's role over here is to convert the diazomethane, the role is to convert the secondary amine looking unit, this nitrogen, to nitrosamine kind of a unit. So you have to attach a nitroso unit over here. Once you attach a nitroso unit over here, then you can create this compound. So let's look at how would this last step of reaction look like. So assume that you already have this nitroso unit derived from N-methylurethane. So CH3 N double bond O, and it reacts with OH minus, attacks over here, and let's say we remove this at one go, and we get CH3 N double bond N O minus plus ETO C double bond OH. This will take up a proton from methyl alcohol, and then OH minus would react in this manner to create a CH2 minus double bond NOH. This will come over here, this will come over here, this will go out. Eventually you will be left with something like this, CH2 double bond N, or you can do it like this, You can take the lone pair over here and you can move it over here and you can remove this. So you would be getting something on the same lines as we had discussed earlier in the previous von Pechmann method, CH2 minus N triple bond N, and this nitrogen has a positive charge. So you again get diazomethane. बाकी ये जो कंपाउंड है इसके साथ रिएक्शन कैसे होगा? So ETO C double bond O OH. So OH minus will attack over here. This will go out and it will become ETO minus, which will eventually get converted to ETOH, plus you will have H2CO3, which will get converted to CO3 2 minus. So carbonate is generated, diazomethane is generated, and please remember diazomethane is created as a gas, and therefore it will drive the reaction in the forward direction. Both von Pechmann methods are pretty easy to understand. The previous one was from N-methyl N-nitrosourea. This one is from N-methylurethane. Both of them involve a similar mechanism. The next method is the McKay method. The McKay method involves N-methyl N-nitroguanidine. इतना बड़ा कंपाउंड आपको याद रखना थोड़ा मुश्किल हो सकता है, but let's see whether it is too difficult to understand the mechanism. So अब देखिए कि नाइट्रोगुआनिडीन में पहले जैसा ही हमने किया है, CH3NH2 का अमोनियम सॉल्ट को नाइट्रोगुआनिडीन के साथ रिएक्शन कराया है. So we have taken नाइट्रोगुआनिडीन. गुआनिडीन इस तरह का दिखता है, NH2 C double bond NH NH2. This is guanidine, and we are taking nitroguanidine over here. So if we are taking nitroguanidine, so it will, rather than a hydrogen, you will put a NO2 group over here. So NH2 C double bond NH NH NO2. Okay. Now when you react this with KOH, what happens is that H2O is created because OH minus takes up a proton. NH3 is created. NH4 actually NH3 plus KCl NH4Cl, and आपके पास ये कंपाउंड निकल के आता है. क्यों है ये आ रहा है? Because this nitrogen must have attacked over here and exactly first method of synthesis के जैसा रिएक्शन हो गया. So अब यहाँ के बाद हमें synthesis करना है. So we have CH3NH C double bond NH NH NO2. Okay, and this undergoes reaction with HNO2. This part looks like a secondary amine part, and this is where the reaction takes place. It turns into a nitroso unit. So CH3 N double bond O C double bond NH NH NO2. Now we react this with OH minus. OH minus attacks here. This splits, this comes over here, and we get CH3 N double bond N O minus. Okay. Next compound is NHNO2 is connected to carbon double bond NH, which is connected to a OH unit. This compound हमने दो बार ऑलरेडी देख लिया है. ये कंपाउंड एक सर्टेन स्टेप्स के थ्रू मूव करेगा एंड इट विल टर्न इनटू CH2N2. ओके, प्लस OH माइनस बाहर निकल जाता है यहां से. OH minus is not that great a leaving group, so OH minus कुछ reaction करने की कोशिश करेगा. So OH minus that is given out will react with this compound, which is the side product. So OH minus will react with HO, C double bond NH, NH, NO2. This will come over here. This will come over here, and this will go out. Okay, and you get something like this: C double bond O, double bond NH plus NH2 NO2 मिल जाता है. Perfect. This compound further reacts with OH minus, and you get C double bond O, OH, NH2, and eventually this further reacts with OH minus, and we get NH3 and H2CO3. So NH3 is obtained. H2CO3 will give rise to carbonate, NH2NO2 is formed, and diazomethane is also created from here. So all these things are created, but remember एक standard mechanism आप देख रहे हो कि the 2 degree amine unit, 2 degree like nitrogen unit is converted into a nitrosamine unit, and then it is converted into diazomethane. Please practice this. This is not that difficult to understand. Let's move on to the properties and structure. So first property is that कि diazomethane at room temperature is a gas. Diazomethane की boiling point around -23 degree Celsius पे होती है, and therefore at room temperature it turns out to be a gas. It is extremely toxic. Okay, so it is prepared during the course of reaction. आप इसको store नहीं करते हैं. It is extremely sensitive yellow colored gas. Actually yellow color का होता है. Extremely sensitive का मतलब ये कि भाई even if the bottle in which this is being prepared has scratches, or if there are any sharp edges in the container, in the flask where it is being kept, उनके contact में आके ये rapidly decompose करेगा, and decompose करके it will be giving rise to a very explosive reaction. So that it can be turned into a contact explosive. Musty odor, and it's strongly carcinogenic. Okay, it's strongly carcinogenic, and it's a popular methylating agent. आगे हम देखेंगे इनके chemical reactions. It's a very good methylating agent. हम लोग काफी सारे जगह पे इसको as a good methylating agent use करते हैं, जैसे कि in carboxylic acids, in phenols, we try to use this. Even alcohols में इसको use किया जाता है ethers बनाने के लिए, methyl ethers बनाने के लिए, and therefore it's a very very commonly very profoundly used methylating agent. अगर इसका laboratory preparation आप देखो तो ये जो ice bath आपको दिख रहा है, या फिर what this ice bath is the one where you can see that this is where diazomethane is collected. So it is imperative to know that diazomethane is going to be a very unstable compound, so we have to use it very carefully. Now the structure of diazomethane looks like this. So CH2 minus N triple bond N, ऐसा ही आपने कुछ बनाया था. Okay, let me just draw it a little better. CH2 minus N triple bond N, and this nitrogen has a positive charge. Now this can come over here and this can create a resonance hybrid, and I can get this CH2 double bond N. Double bond N can be a positive charge and a negative charge, this nitrogen atom. Okay? Is that understood? Some people can also draw this, or in fact a lot of people do end up drawing this as well. और एक बार जेई में ये सवाल भी पूछा गया है कि draw the stable canonical forms, or arrange the different canonical forms of diazomethane in their relative order of stability. So some people do draw it like this as well. N double bond N, and this nitrogen ends up having a positive charge. ये काफी अनस्टेबल स्ट्रक्चर है ये, और इसका एक कैनोनिकल फॉर्म बनाते हैं CH2 plus N double bond N minus. Okay, so in this case यहाँ पे दो लोन पेयर हो जाएंगे. अगर आपको किसी ने बोला कि let's say this structure is A, this structure is B, this structure is C, and this structure is D, and you have to arrange them in their relative order of stability, then the first rule set is that if something has lesser number of bonds, it will be less stable. So but A and B have to be more stable than C and D. Between A and B, B will be more stable because the negative charge resides on nitrogen. Over here the negative charge resides on carbon. So B will be more stable than A. Now between C and D, nitrogen with a positive charge is less stable than nitrogen with a negative charge. So BA, then D, then C will be the order of stability. Canonical forms. Okay? So let's move ahead and let's start with the chemical properties. So सबसे common chemical property इनकी क्या होती है कि they are being utilized to prepare methyl esters from carboxylic acids and methyl ethers from phenols. इसमें हम alcohol का भी reaction include कर सकते हैं, और ये reaction दिखता कैसा है. So actually होती क्या है बात कि RC double bond O, OH is being made to react with diazomethane. CH2 minus and triple bond N, इसके ऊपर एक positive charge. This CH2 minus सबसे पहला reaction एक acid base reaction होता है. Okay, the first reaction is an acid base reaction. So CH2 minus takes this proton and आपके पास एक carboxylate unit generate होता है, and you get CH3 N triple bond N plus. So the first reaction is an acid base reaction. Second reaction is this turns into a good nucleophile. Okay, RCO minus becomes a decent nucleophile. I would not say very good, but it's a decent nucleophile. So if it becomes a decent nucleophile, it attacks on the carbon and nitrogen goes out as a leaving group, and it undergoes a SN2 reaction to create the methyl ester. Okay. Similarly, same reaction हम phenols के साथ कर सकते हैं. If you take phenol and phenol को आपने CH2N2 के साथ reaction कराया, so exactly same reaction होगा, same pathway will be followed. You will get O minus plus CH3N triple bond N, nitrogen with a positive charge, and this will attack over here, this will go out, SN2, and we would get OCH3. सेम रिएक्शन आप अल्कोहल्स में भी कर सकते हो. अल्कोहल्स को ईथर में कन्वर्ट करने के लिए भी हम ये यूज करते हैं. ROH plus CH2N2 is utilized to form ethers. How? I get CH3 N triple bond N plus, and then a SN2 reaction occurs, and we get ROCH3 plus N2. But हमेशा याद रखिए कि phenol will get converted to anisole. This is only a methyl ester, always a methyl ester, and this is an ether with one alkyl group which will always be a methyl group. कोई और alkyl group डाइजोनियम सॉल्ट डाइएजोमीथेन यूज करके आप नहीं ला सकते हो. ओके, द नेक्स्ट मेथड इज aldehyde, or the next reaction is where aldehydes can be converted to methyl ketones, and ketones can be converted to their higher homologues using diazomethane. ये काफी इंटरेस्टिंग सा मेथड है, and it's not a difficult one as well. आप इसमें एक aldehyde को, you can take an aldehyde RC double bond OH and you react it with diazomethane CH2N2, and you will be getting a ketone. Okay, you'll be getting a ketone. Just write a little above. If you use any ketone like RC double bond OR, कुछ R लिख दिया गया, and you react this with diazomethane, then you will get the higher homologue. Higher homologue means a CH2 will get inserted between the carbonyl and the alkyl group. And how do we write or how do we understand that this part, how is this happening? Okay, so aldehyde वाला पहले समझते हैं. So RC double bond OH, it reacts with CH2N2, so it attacks over here. This turns into a tetrahedral intermediate. Now CH2 is connected to a very good leaving group. So this negative charge comes over here, and there is a proton transfer which takes place to carbon, and nitrogen goes out. So 1, 2, 3. R C double bond O CH3. Okay. Perfect. So there is a hydride shift which is occurring over here, H minus shift, which is occurring over here. Similarly, अगर आपने कीटोन में ये किया, in that case, there will be a alkynide shift. This will shift. Alkyl group will shift. 1, 2, 3, and we would get RC double bond O CH2 R plus N2 gas. Nitrogen is going out as a gas, which drives the reaction in the forward direction. Okay? Chलिए. Let's look at the next chemical reaction. So the next chemical reaction is ring expansion. So ring expansion can be performed using diazomethane. For example, अगर आपने cyclohexanone लिया है, cycloheptanone बना सकते हो. If you have taken cyclopentanone, then you can convert it into cyclohexanone. Method क्या होता है? काफी simple सा reaction है ये. So this is your cyclohexanone. This is made to react with CH2N2. So it attacks over here and it creates CH2N triple bond N with a positive charge. So therefore, at this juncture, this comes over here, and this ring, see, the sigma bond migrates, and therefore this N2 goes out. So 1, 2, 3, and we get O and N2. ठीक है? So 6 members से 7 member बन गया. You can make 5. You can make a 6 membered from a 5 membered. Okay. So it's a pretty interesting reaction. Next, synthesis of nitrogen containing heterocyclic compounds. So diazomethane reacts with alkenes and alkynes as dipolar ions to form pyrazolene and pyrazole derivatives respectively. Let's see how this works. So ये अगर alkene है, if this is an alkene, then it will react with CH2 minus, and I'm saying that it is behaving as a dipolar species. So हमें इसको इस तरह से बनाना है. Okay. So this will attack over here, and this will attack over here, and we would get something like this. CH2, CH2, N, H2, N. Just draw it properly. I'll get this. Okay. लेकिन इस स्टेप में इसके बाद क्या होता है कि एक प्रोटॉन यहां से रिमूव हो जाता है. So this proton is removed and it is accepted at this nitrogen. So I would say plus minus H plus, and we get something like this. Okay, this is a pyrazolene. If I perform a reaction with alkyne, C triple bond CH. Then similar reaction chalega, but then you will get a pyrazole, you will get an aromatic compound. So this will attack over here, this will attack over here, and we will get C double bond C H H CH2 N. There is a nitrogen, there is a double bond, and then again we will do the same thing, plus minus H. So from here that proton will be removed and we will get something like this. You can see that it looks like an aromatic compound. It is an aromatic compound. So this is a pyrazole system. Okay, it's a pyrazole system. Perfect. Chale. Next reaction is, if I take a ketene and I react it with diazomethane, I'll get a cyclopropanone. Very interesting reaction. This is a ketene, CH2C double bond O. And अगर इसको मैंने CH2 minus N triple bond N इसके साथ reaction कराया, I'll get a cyclopropanone unit. बहुत simple सा reaction है. होता क्या है कि this CH2 minus attacks over here and we get a CH2 minus C double bond O, and we have CH2 N2 plus, and this attacks over here and this goes out. 1, 2, and we get double bond O. Okay. Next, Wolff rearrangement and Arndt-Eistert synthesis. Please remember कि ये हमने पहले पढ़ा है. हम करते क्या है in this reaction is that we react carboxylic acid first with SOCl2 to prepare acyl chloride. We take a carboxylic acid and react it with SOCl2. You will get RCOCl, which is then made to react with CH2N2. Okay, so होगा क्या कि ये कार्बन के ऊपर नेगेटिव चार्ज है, that will attack over here. So there is a negative charge that will attack over here. This will go out, and we would get R C double bond O CH2 N2. And if this is being heated, this is known as a alpha diazoketone. Alpha diazoketone. If this is heated, you would be getting a ketene. Okay, you'll be getting a ketene, RCH double bond O, sorry, double bond C double bond O. You would be getting this species. This is the ketene, and this reaction is known as Wolff rearrangement. इसी को बोलते हैं Wolff rearrangement. इसके बाद अगर आपने ketene को water के साथ treat किया, you will get a higher carboxylic acid RCH2COOH. तो ये पूरे reaction को बोलते हैं Arndt-Eistert synthesis, within which Wolff rearrangement is occurring. This step is Wolff rearrangement. This whole conversion from this carboxylic acid to this carboxylic acid is the Arndt-Eistert synthesis. Now how does this reaction take place? Diazomethane to ketene कैसे बनता है? बहुत सिंपल सा है, आप इसको पहले की तरह ही कर सकते हो, R C डबल बॉन्ड O CH2N2, ठीक है। अब आपने इसको हीट किया, लेट्स से इसको मैंने इसको थोड़ा ऐसा दिखा दिया, N ट्रिपल बॉन्ड N विथ पॉजिटिव चार्ज, ये ऐसा दिखा दिया, ओके। सो ये जो होता है, दिस रिएक्ट्स विद अ बेस, ओके। एक्चुअली यहां पे जो Cl माइनस निकला है, दिस Cl माइनस takes a proton from here and it creates RC double bond O CH minus N triple bond N with a positive charge. Then it comes over here, this comes over here, and this goes out. 1, 2, 3, and we get RCH double bond C double bond O. यही है वुल्फ रीअरेंजमेंट, ठीक है। ये आपने पढ़ा भी होगा, ये हमने पहले डिस्कस भी किया है। इन वन ऑफ द प्रीवियस सेशंस वी हैव डिस्कस्ड वुल्फ रीअरेंजमेंट। एंड द लास्ट reaction is that we can use an alkene and you can use diazomethane to prepare a cyclopropane and its derivative. So thermolysis or photolysis of diazomethane produces methylene, it's a carbene, and this carbene inserts in that alkene to create a cyclopropyl ring. फॉर एग्जाम्पल इस तरह से रिएक्शन चलता है, CH2 माइनस N ट्रिपल बॉन्ड N प्लस, एंड सपोज यू हीट दिस, या फिर आप सनलाइट यूज किए, ओके, इलेक्ट्रोमैग्नेटिक रेडिएशन, सो दिस विल स्प्लिट एंड वी विल गेट a carbene. This is known as a carbene plus N2. यही कार्बीन एक एल्कीन के साथ अगर रिएक्शन करे, then we will get a cyclopropyl system. This is what we would be obtaining, cyclopropane. इनफैक्ट काफी इंटरेस्टिंग सा फीचर ये है कि इफ यू कैरी आउट दिस फोटोलाइसिस ऑफ डाइएजोमीथेन इन प्रेजेंस ऑफ लिक्विड सिस टू ब्यूटीन एंड सिस और ट्रांस टू ब्यूटीन, सो इफ फोटोलाइसिस ऑफ CH2N2 is carried out in liquid cis to butene or trans to butene, then the carbene which is created, okay, does not, so जो carbene create होता है वो singlet carbene create होता है, which does not get enough chance to get converted into the relatively stable triplet carbene, and therefore एक स्टीरियो स्पेसिफिक रिएक्शन हमें मिलता है, एक स्टीरियो स्पेसिफिक रिएक्शन हमें मिलता है, ओके। व्हाट इज द मीनिंग ऑफ ए स्टीरियो स्पेसिफिक रिएक्शन? सिर्फ एक ही तरह का प्रोडक्ट, मिक्सचर नहीं मिलेगा। सो सपोज ये आपके पास एक सिस टू ब्यूटीन है, and this is being made to react with CH2N2, अपने हीट किया, फोटोलाइसिस किया, ओके, एंड the product that you would obtain will be something like this. The orientation of hydrogen and the methyl groups does not change. Okay, इसको मैं photolysis है ना, so heat नहीं करते. Okay, so that's all about the reactions of diazomethane and preparation and properties. Please go through this and remember that diazomethane के reactions काफी ज़्यादा prevalent है. Exclusively Wolff rearrangement, reaction with alkenes, ring expansion, and conversion of alcohols into ethers, acids into esters. So that's all for today, guys. I hope you have enjoyed the session. Please join us the next time for another reagent. Until that time, please take care, bye-bye, and have a lovely time.